All right, guys, welcome back to exponential functions.
We're continuing what we were talking about in the last video.
We are. We're going to take it a step further to word problems. We're actually asked to calculate a value. All right, so we're going to pick some of these word problems and show you A, how to write an exponential function, and B, how to plug in and actually solve that exponential function.
Excuse me.
Ms. Doug is going to remind you about our growth equation and our decay equation.
Remember, all generic functions, exponential functions, can be written as the form y equals a times b to the x, where a is our initial value.
Yeah, remember that's our starting point. So you're going to see a lot of that used in these word problems.
And b is our boss
That's
that can be
right.
broken down.
He has the power.
It just depends on what's going on. So b can either be 1 plus the rate.
That's right.
Or 1 minus the rate. Now remember, when you're substituting into this formula where you've broken it down, the rates must be used as a decimal. So when we're using them in the formula, we'll be using them as a decimal. But usually in the sentence or the word problem, they're given to us as a percentage.
That's true.
Okay. All right?
We're ready.
So
Let's go.
Let's start with number
9. Okay. It says the first year of a charity walk event had an attendance of 500.
So that's the beginning value. As soon as I see that, I'm going to underline it because that sounds like our starting point.
Yeah, first year of something, that would be your starting point. All right, the attendance, Y, increases by 5% each year.
Increases. As soon as I see the word increases, that tells me that we're growing.
So we're definitely adding. And then 5%, think about 5% as a decimal.
That would be 0.05. Remember, to go from a percent to a decimal, you take the decimal that's there, whether you see it or not, move it 2 times to the left.
Okay, so they basically give us everything that we need. Here's how you know it's exponential. Remember that if it's increasing or decreasing by a percentage, it would definitely be the exponential.
True statement.
Okay. All right, so A, they would like us to write an exponential growth. Oh, they're already telling us it's growth function.
Normally they don't always tell us that, but these do.
Definitely.
We knew it though from the word problem.
Yes.
So exponential growth function. So functions are f of x. Remember, f of x is a synonym for y.
That's been a long time.
Just
we haven't talked
fancy.
about that in a while, but we definitely need f of x.
So f of x is equal to a, which
Remember
are
our initial
value,
value.
times
B.
1 plus our rate.
So our rate would be 0.05. And then we're going to raise it to the x.
Now, while that answer is nice, it's not perfect because it's not simplified.
That's right.
Technically, I can put together 1 plus 0.05, so I can actually have that b value no longer broken down. Remember, b can be broken down. I don't like for it to be in my simplified answer.
Yeah, we like it to be simplified.
So, best answer would be f of x
Yes. Function, remember,
equals our initial value
500 people came the first year.
times 1.05.
Growing greater than 1 to the x. Look at
Now,
that.
sometimes you'll see, instead of an x, you'll see t for time. It just depends. Okay, so how many people will attend in the 10th year? 10th year, that would be our x value. So I'm going to substitute in 10 for x.
They would like the 10th year.
So 500 times 1.05 to the 10th power. And we would type that right smack down in a calculator.
I would.
Just like Ms. Fisher has done for me.
Yes.
Okay, now we got to talk about this because these are not going to give you nice, pretty decimal answers. We are talking about people. We're talking about a living thing. I don't care if it's people, rabbits, penguins, squirrels.
That's right.
Doesn't matter. If it's living, we have to cover this decimal portion. I know that there's no such thing as 0.4 for people. It's just not going to happen. But to cover that, you always have to take this amount and round up. You always need more not less. It's like
That's
when we were
right.
doing Thanksgiving. You make more food rather than less. Everybody needs some plus some extra. So with population, we take our decimal, we always round it up, no matter what, because you got to cover this decimal portion.
Even if it was 814.03.
Because look, 0.4 technically does not round up. It doesn't. But to cover that 0.4 of a person, we're going to round this up. So we're going to say that in 10 years, the charity walk event will have had 815 people.
And notice that the word problem said to the nearest person. So you do not write a decimal of a person.
And I know that normally we would not round up.
Right.
Technically, we would never round up in math with this decimal because 0.4, let it rest.
Yes.
But cover that 0.4 of a person, you have to have more, not less.
True. Okay, look how easy that is, guys. Super easy. All right, we're going to do number 10, next one.
Population. So as soon as I see population, I know that when I get to this B part, I'm going to have to always round up.
Yep, those people.
Okay.
All right, the population of a small town was 3,600 in 2005.
So 3,600, I would say, is my initial value. So we started
Definitely.
with.
All right, the population increases. There's that word we like. It's going up. So we know it's going to be growing. Therefore, we know it's going to be adding. All right, by 4% annually. So think about 4% as a decimal. Miss Depp quickly did that in her head. That's 0.04.
And notice that we're making this word problem for annually. So this is per year.
Yeah. All right, first part. They want us to write an exponential growth function. Again, there's that growing word. We already know it's growing because of the word problem. Miss Depp started it with f of x because we know it's a function.
Synonym for y.
And remember, that means that every x would have exactly one y. So notice she has initial value of 3,600. She's breaking apart that b just to show the math for a second. It's 1 plus the 0.04 raising to the x.
Simplified function is always best.
Yes.
F of x is equal to 3,600 or 3,600 times 1.04 to the x. Okay. Now I'm going to use my function to find the population in 2025. Now remember, I told you we wrote this for years.
That's right.
Annually is per year. I'm not going to sit here and plug 2025 in. That's not going to help me because then we're saying that it's been 2025 years.
That'd be a long time.
It's technically only been 20 years because I started in 2005 and now we're in 2025.
That's right.
So that would be 20 years. So that's what I'm going to substitute in.
Okay.
I'm going to say f of 20 is going to be equal to 3,600 times 1.04 to the 20th power. Now we are talking about population, so we're always going to round up regardless of the decimal. I don't care if the decimal is 4 or more, 5 or less, whatever. We always go round up. So Miss Fisher has been nice and plugged in the calculator for me. Notice that we've got 7,888.04. Technically,
there's a good one, yeah.
0.0 is a 4 or less, so normally in math we would let this rest. But in order to cover that 0.04 of a person, you need more,
That's right.
not less. So I'm always going to round up. So that's going to be 7,889 people.
So if the population of that town continued to increase by 4% annually, in 2025, they're estimating that it would have 7,889 people.
Yep.
Okay.
People, living things you always round up.
Yes.
Anything living.
And exponential word problems are used all the time in real life. These are real life circumstances.
Technically, we could come up with an equation for the COVID.
Cover
We
the
could figure
COVID.
out how many percent of people have had COVID or whatever. That's what the scientists are doing.
Yes.
So, anyway, we'll move on.
Here we go.
Let's do another one.
So-
Your starting salary. So we're no longer talking about people or anything living. Now we're talking about money.
Yep.
So this is something that a lot of people do to figure out their salary.
Uh-huh.
Your starting salary at a new company is $34,000. That starting point would be our A value. And it will increase, once again, increase.
Goes up. We're growing.
So it's growth.
Gonna add to that 1, remember?
About 2.5%. I'm going to move the decimal 2 times to the left, so that'd be 0.025 as a true decimal.
Yes.
I know that there's a decimal in the percent, but that's not its true decimal form. We have to move the decimal 2 times to the left to get it to its true decimal form. Now I'm ready to write my function. So f of x is equal to,
The starting salary for this person was $34,000.
It's a good starting salary.
Yeah, it is. Yep, kind of like a teacher. All right, then remember that B, we're gonna break that part of B, we're gonna add 1 plus, because we know it's increasing, and then that .025. We're gonna raise it to the X to make it exponential because it was increasing at a percentage rate.
And then we're gonna simplify that. Sorry, that was my phone. So f of x is equal to 34,000 times 1.025 to the x. So there's our perfect function. Now we're gonna use our function, what will your salary be in 5 years? We wrote this per year, so we're just gonna plug this in for x. So f of 5 is gonna be equal to 34,000 times 1.025 to the 5th power.
Yeah. All right. I've done your math for you.
Yep, isn't that nice? Now it says round your answer to the nearest dollar. So dollar would be the whole number. So I'm going to look at its decimal. If it's 4 or less, we let it rest. If it's 5 or more, we add 1 more. Well, 8 is definitely 5 or more, so I'm going to add 1 more. So that's going to be $38,468.
To the
Round to the
nearest
nearest dollar.
Just watch how they word that word problem, because that's the little things they'll get you on.
Yeah. So people, you always round up. I don't care what. Money, you round to whatever they tell you to round to.
All right.
Okay. Let's skip and let's go do some down here.
Yeah.
Let's do number 14.
Yeah.
Okay.
All right.
You bought $2,000 worth of stocks in 2012. Well, that sounds like our
That's what
starting
we started
value.
with. That's what we bought.
And notice that it's in the year 2012, so I'm going to circle
It's
that
probably going to be
year.
important sometime.
The value of the stocks has been decreasing. That was not a good investment.
No, if you're
Decreasing.
losing money on stocks, you definitely didn't do well.
That's a decay, so I'm going to be subtracting by 10%. That'd be 0.10 as its true decimal. So write a function.
F of X. That initial value, remember we bought $2,000 worth of stock in 2012, so our initial value $2,000. And then we're going to multiply it by 1 minus, because we're decreasing, remember decaying going down, and then that 0.10. And we're going to raise it to the X to make it exponential.
And then simplify it completely.
Definitely.
So f of x will be equal to 2,000 times.
Think about that as money. That's $1 minus 10 cents.
Now you can leave it
Easy.
as 0.9 or 0.90. It doesn't really matter. Just know that they're equivalent to the x. What will our stock be in 2017? We got to figure out how many years has passed from 2012 to 2017. That would be
5 years.
5 years. So I'm going to substitute in 5 for x. So f of 5
is equal to 2,000 times that 0.90 going down to the 5th.
Okay.
All right, I've done the math. Let's see what our word problem says. They want it to the nearest cent, Miss Delk. That one comes out perfectly.
Nearest cent would be right here. Remember, the nearest cent is always the second decimal, and there wasn't any other decimals after that. So technically, this is exactly what it should be. So if we had a number out here, we either would have rounded up to 8 or we would have kept it as an 8. So in 5 years, our money has gone down.
Don't invest in that one.
Yeah.
Notice that I'm using this calculator and I'm just plugging it in exactly as Miss Delk is writing it, and it will do the math for you as long as you plug it in exactly as you would write it.
Yep, they're kind of great calculators.
All right.
Okay, let's do one more.
Okay.
15. Your car costs $42,500. That's the starting amount. That's what you
That was
paid
a nice
for.
car when you bought it.
So there's my A value. When you purchased it in 2015, I'm gonna go ahead and circle 2015.
Yeah, we're gonna need it.
The value of the car decreases, depreciates. Anything of that type of word always indicates decay, which means we're going to be breaking down our B by subtracting it by 15% annually. 15%, we 0.15 as its true decimal. So function
All right, here we go.
notation.
I've kind of gotten used to the pattern. So A, what we paid for the car was $42,500. Miss Delk's going to multiply that by 1. Perfect number in algebra, but we're going to decay. So we're going down, decreasing by 15%. And we're going to raise it to the X.
Simplify it.
So F of X.
42,500 times $1 minus 15 cents will be 85 cents. That's how we do that really quickly without a calculator. Of course, if you had one now, just type it.
But a lot of y'all can do that in your head.
You should be able to do that in your head.
All right.
Okay. They want to know how much is the car worth in 2022. So how many years has passed from 2015 to 2022?
That's 7 years.
7 years. So I'm going to substitute in 7 for X. It's the reason a lot of times in word problems, instead of an X, they'll use a T. Because a lot of times when we're dealing with word problems, it's time.
That's all right. Okay, notice they want our answer here to the nearest dollar.
So
Okay, and I wrote it exactly, put it in the calculator exactly as Miss Delk wrote it. So after 7 years to the nearest dollar.
So here's our dollar. We gotta look over. That's 5 or more, so I'm gonna add 1 more. So
That's right.
in 7 years, my car is now worth nothing.
Definitely taking a hit.
$13,625, which is pretty much accurate.
Yeah,
for
this is
vehicles.
definitely what used car places, so when you're trading your car in, stuff like that in life, this is definitely how they're using math to come up with what your car is worth at that time.
And a lot of times, what they'll do is this is how much they know they can sell the car for.
Yeah.
And so they'll offer you less than this.
That's right. Good luck.
Have fun with that.
All right, well, that was exponential growth and decay word problems. You see, they're pretty easy. You're basically writing the growth and decay function and then plugging in for that X value, what they're asking you to figure.
Remember, A is the initial value, B is the boss because he has the power. He can be broken down into 1 plus the rate or 1 minus the rate.
Okay. Stay tuned for graphing exponentials will be your next video.